do miss my science. This is something that I presented at the Festival of Teaching a couple of weeks back. It was an hour workshop, so we're down to 15 minutes. So chopped and changed and moved a few things. The crux of what I was getting at was engagement in maths is often poor, particularly around our middle years, year 8 and 9, where we're in the middle of the tunnel and we can't see the light at the end at the moment. And what we're getting is a lot of black line masters with shapes or with algorithms that we have to complete. So I tried a different tack, something completely different to what I normally do. These guys are about experiment 3 or 4 along my journey to be more inquiry-based and more open to what students would like to do in my classroom. So we have a unit in year 8 called measurement. Every year has a measurement topic. The final assessment task was designing a bedroom, and I thought that was great, and I had designed the unit to be an interior design sort of context, and I was trying to make sure that everything we did came back to bedrooms and what they would look like, because they're going to have to design one at the end of the unit. We started the unit with a word wall, which I thought was going to be a great activity, very simple. Everyone gives up a word that matches measurement. And what I got was completely not what I had expected. So all my normal units came out, centimetres, area, inches even, and we were almost done, and someone said light years. And I went like, wow. And I said to the student I had scribing, yeah, pop that one up, that's a measurement. And the whole class went, what do you mean that's a measurement? What is that a measurement for? And they immediately had a few Googling, and then, oh, it's this. I don't actually know the measurement for light years. 9 point something times 10 to the power of 15, something like that maybe. They've never seen a number like that before. So, and it was actually written as e to the power of 15. So what is that? And then more Googling, and that means it's this big, and drawing it up on the board and stuff like that. It became very obvious they weren't interested in bedrooms anymore. And I was crushed because I had spent hours looking at interior designing. I was starting to look at magazines to buy about houses so that we could pass them around, have a look at perfect rooms set up perfectly. And I just remember standing there for a moment, listening to all of the excited chatter about what it was. I remember making a comment like, well, that's how big you think a star is, then my idea of what big is nowhere near your idea of big. They couldn't conceive of the fact that the sun's actually bigger than us. Like, it's actually much bigger. I ended up putting on that clip where you see the relative sizes of things, and they were all like, oh, whoa, what? So obviously bedrooms went out the window. And leaving that lesson, and I got to the point where I said to them, would you like to do something about space? Of course the answer was yes. So I made this unit to accompany that excitement, because it was like unheard of in a maths classroom. I didn't want to lose it. And so we started with this thought at the beginning of the next lesson, and we pondered that to come up with our statement of inquiry, that man must rise above the earth to the top of the atmosphere and beyond, for only thus will he fully understand the world in which he lives. Now, I am a bit of an adventurer. I love space, I love science. I didn't want to go too far outside of the atmosphere. We chose the International Space Station. With a heavy hand, like I had to walk them towards that. Distances between planets and stars are just so great. And what we had to look at was the area of a rectangle, the area of a trapezium. So we can reach for it, but we had set content to cover. So we started thinking about where is measurement used in the International Space Station, and that idea that if you don't get it right, what could go wrong? And that the consequence there is just so large. Like, if you don't send up enough of that aluminium to fix the solar panel that broke, what's the consequence of that? So it was an excellent area to explore. And there it is there. We actually pulled in that reasonableness of our calculation, the degree of accuracy you would need to build something like that, and the consequences if you didn't reach those. So, and those solar panels there, was that 16 solar panels, they did recently break. They fan in and out, and they moved them to face the sun and stuff. They opened them up one day and one of them caught and it ripped all along, so they had to send that much solar panel back up on the next rocket that was sent. But it just opened this huge realm of I wonder, which was Elsby's sort of starting there. I wonder what they do to get stuff up there. I wonder what you have to do to be an astronaut. I wonder who built that and what country does that, and stuff like that. So we actually spent a couple lessons at the beginning wondering and researching. We wondered about size. It's actually the size of an American NFL football field. Oh, wow. Well, how big's that? And then the first answer I got was, well, obviously it's about, 100 yards. Well, how big's a yard? And so we had to actually learn how to convert, and we had to learn where to go to find conversions. How do we put that into Google so we'll get the right thing up? And then we got 110 meters. So we tried to think about things that were 110 meters long that were around us, and the oval was just under 100. So that gave us a good idea of the size. My room became full of posters like this, where, and I'm sorry I can't read any of the things I've got up there. They thought about the contributors, and it is a number of countries. It's Japan, Canada, USA, Russia, and the European Space Agency, which is a large number of different European countries, which brought up questions about how do they communicate. They've got different systems of units. How do they even make things that go together, and things like that. And we spent a lot of our unit just sort of pondering. Every lesson we had the introduction to the maths. There was always that same black line master they're always going to get, but we had a reason to apply it now. We were starting to think about the shapes that made up the space station. We were starting to wonder how they knew how much stuff to send, and we had a purpose for using the black line master. So that always made up a portion. Towards the end of the lesson, we would have a clip. I had to have a question bucket because there were just so many questions. I couldn't answer them all on the hop, and I don't know the answers to a lot of them. So this big, huge question bucket, and everyone would put questions in, and I'd pull one out and go, YouTube that, and put on a quick little clip. Usually, Chris Hadfield, he's amazing, and even some of their projects had Chris Hadfield in them once they started their designing phase. We shifted the assignment, so I went from we're going to design a bedroom to we will design a habitation module upon NASA's space station. It was the last module to go up, and it only went up recently. Until then, they slept in the labs, and so they've never actually, until recently, had a place to sleep, and so we wondered about what that would look like to sleep there. This is one of the most famous windows in the universe. That's the cupola module, and it's a lovely, lovely place to sit and think. It's also made up of a number of different shapes, which we had to learn about. So the trapezium's in there for the windows. We had to learn about the area of circles and stuff like that. So this was one activity I used. I actually found a diagram with the specifications for the size of it. And whilst some of us worked away on just finding the basic areas there were students who used the scale, were able to use the scale in order to find how much glass you would have for those windows. And so whilst there were students I still sat with to do rectangles and do the black line masters of the trapezium, my top kids could then take those diagrams, those schematics, create their own questions. This one was the glass, and then solve those and have a context to why they were doing it, I suppose. So that introduced us to scale. Our assessment task was designing our own module, and that I left open. I tried to convince them it should be a cylinder because all of the modules were kind of cylindrical in some sense, but I'm just the teacher up front that's not as creative as everyone else. And so I got all sorts of things. This is a side-on view and a top bird's eye view of the same module. This student really thought about even the coupling. We watched a clip about how Russia and America had different coupling. So they did combine the Mir space station and Skylab 2000 and something, and they thought about what the coupling would look like. There was lots of concerns there. This other student with the two circular ones, happening as this unit was occurring, and I had no idea it would be, they are testing the modules for the Mars mission. And this module was sent up, and I cannot remember the name of it. It expands so you can live in it, but if you don't have people, you can retract it and not waste the air and the volume having it open. So they're little bedrooms that kind of get floated up there, attached to one of the nodes, and then expanded out with air. This student was just absolutely encapsulated by it. His design was an octagon with 8 bedrooms. We did research that it was about maximum 6 astronauts up there, but he thought by the time his got made, that 8 would be going. So that was good. And the student over the other side, she stuck with the rectangular. She wasn't ready to go to cylindrical looking things or hexagons or any of that. She stuck with her rectangular design. Looks very much like a bedroom would look. She's got Chris Hadfield's guitar floating around and stuff like that. She thought more from a design perspective than I would have thought they would have. She was really thinking about your sit-down furniture, your normal furniture, living a normal life in space. And that actually became something they were really fascinated about, because I drew with them. I did the task with them so they could see me, and I would put my drawings up on the whiteboard every lesson. And one lesson, I decided mine was actually rather tall. It was really wide. So I put the exercise equipment on the roof, and so they would be running upside down, and I showed them some photos. That's currently what happens. So you'll be floating through a module and you look up and someone's running above you. They tether themselves with ropes. I said, that's what I would like to have happen. And they went, oh my God, all this space, all this volume above them. Yes, I can do something. But unfortunately, Alyssa couldn't get past the thought of having it like a house. But it was an excellent unit, and I wouldn't normally allow that scope. I mean, I had a wonderful unit about bedrooms and houses, but they were so excited, and it was every lesson and more questions. And when we did perimeter, and I asked them, where would you use perimeter? They said the wiring. The wiring in there, you'd have to have a perimeter for that. And they looked up the amount, and it was something like 18 miles of electrical wire up there. And they would often prompt me after that point. So if I showed them the formula for a trapezium, they would say to me, well, where would you use that? I said, I don't know, let's get the picture back up and let's have a look. And we would look, and then we had a booklet which had all the specifications, so we could actually use volume and area formulas on the existing modules. It was fantastic, and I really would recommend it for other people to allow them to have that, because they directed a lot of their learning. It was almost hands-off. I had to make sure I had printed the sheets, and I had an idea this lesson. I'd like to do circles, but they often took me to where we needed to go, and they would direct me what they needed to do next. We really haven't looked at the circles yet, miss, and there's a circle there, and there's a circle there, and they would tell me. So it was good. My last thought comes from Alyssa, because she was so concerned with design, and I could see how this would cover over to a design. She really wanted them to live normal lives, and for that you couldn't be floating around all the time, so she put Velcro on the bum of some pants so that you could actually sit down and eat your dinner. So if anyone design wants to link up with me next year for Year 8 and they can design some things that would be useful and innovative, there's potential there. She submitted that on her assessment task. It was an important part I had to have. So yeah, that's about it from me.